Right, so I mentioned in my last video, Mathelingual, again, I mentioned in my last video that now we're going to look at some inequalities. So really this is just going to be an intro. The big chunk of like properties will be in the next few videos, I think. But I think it's important to establish a good foundation, a good intro at least, so we have a prior understanding of what we're thinking about. Oh, one thing I forgot to add on the last video, I'm just going to bring it up real quick. The last temperature equation we worked on, Kelvin plus equals Celsius plus 273.15. Now think about that. That's a literal equation. So think, is it always, sometimes, or never true? Because sometimes you have equations where only one value of the variable makes the equation true, right? We saw that with equations where we had to solve for that one variable, right? But this is different. There are two variables. So you think of it, this is an identity, as is the other temperature related one. So Celsius equals 5/9 the difference of degrees Fahrenheit minus 32. These are both identities, okay? Because that means you can plug in any value of your variable and you will make the equation true, because really all you're doing, you're just going to get that temperature in another unit of degrees, right? Be it from Fahrenheit to Celsius or Celsius to Kelvin, right? So I just wanted to bring that up because you may not realize it at first, because it's an equation and we tend to think of equations, I think sometimes, as having that one or those few solutions, like say with a quadratic equation where you'd have two solutions, or a cubic equation, or whatever, right? But these are identities because you can plug in whatever. I mean, I could plug in whatever temperature I want and I'm going to get an equivalent for that temperature, whatever it may be. Okay, so I just wanted to emphasize that a little. Now we can actually move on to inequalities. So the difference between inequalities and equations is you're going to see the signs. So how do we write and graph inequalities? Well, usually we're going to use a number line for graphing. So let's start with this. Okay? X is greater than 4. And maybe for a lot of you this is just really basic knowledge, but the one way I was able to remember it when I was a little kid learning this stuff is that you imagine this is like a fish or a shark or something. You just imagine that's its mouth and it wants to eat the bigger number, right? So like in this one, since the mouth is facing toward X, that means X is going to be greater than 4. So X is greater than 4. Pay attention to these terms because this is going to be really important for when you graph it. And similarly, X is less than 4. Okay? X is less than 4. Okay? And then there's also two other special cases. You might also see this. Okay? It's got that little line. That means X is greater than, okay, so it's greater than, right? Just like up here, or equal to 4. Okay? So it can be more than 4, it can be bigger than 4, or it can be equal to 4. And then the last one, X is less than, or equal to 4. So it's a similar principle here. You've got your greater than or your less than, right? But when you've got that line underneath, that means you're saying it could also be equal to that number. So how does this look on a graph, you might ask? Well, let's see. I'm going to draw a number line. Okay, let's say we've got points. It doesn't really matter how many marks we're putting on here, but I'm just going to label it just for convenience a little. Okay, so let's say we're starting with X. I'm just going to use the same number line. I think that should make it simple. Okay, so X is greater than 4. What you're going to do, you're going to draw a circle at 4, your point, and then you're going to draw an arrow, so it's like pointing, you know, it's going that way, right? This is X is greater than 4. I'm just going to set this down here So x is greater than 4, you see? Because this open circle means that this 4, the point at 4, is what we call a boundary point, okay? A boundary point, because it separates the inequality from the rest of the number line, okay? So here, with that circle, it is an open circle. That means we are not counting 4 as a solution. So if you say x equals 4 for the inequality x is greater than 4, that's wrong, okay? Because when we say x is greater than 4, we are saying everything bigger than 4, okay? We're not caring about 4, okay? That's why the circle is closed. That's why the circle is open, okay? So, open circle means that number is not a solution in the equality. But if I do this and I make it greater than or equal to 4, then I'm just going to color in that circle. And now it is a solution, okay? So now we can say x is a solution. X equals 4 is a solution, I should say. Because that means now we're talking about everything bigger than 4, but we can also talk about 4 itself, okay? So now with the other two examples, this works in a similar way. So, just nothing much to erase, luckily. Okay. So, now let's say I'm talking about x is less than 4, okay? I just talked about x is greater than 4 and x is greater than or equal to 4. But x is less than 4, you're still going to draw that circle at that point. But now you're just going to go in the opposite direction, right? Because we're talking about things that are smaller than 4, right? Now look at this. Open circle, 4 is not a solution, okay? Because 4 cannot be less than itself. That makes no sense, okay? But if I do this and put the line under, that turns it into less than or equal to, which means we then color in the point. So it is a solution in that case, all right? I think that's pretty clear. So just in general to remember, an open circle means not a solution. Or sometimes I like to abbreviate solution like this. I just learned it from my chemistry solution. But then a closed circle or a colored in circle is a solution, okay? So that is the key difference between this. So this one would have a closed circle, right? Because you say it's blah blah or equal to, but these are going to have open circles because they don't have that equal to part. It's either greater than or less than, okay? Okay, now the last bit of this example that I want to show ties back a little bit and might remind you a little bit of one of my earlier videos when I talked about algebraic expressions, how you can create expressions from the words. So remember when we had something like x 7 fewer than a number x, okay, right? And I remember saying, you know, be careful, this does not mean 7 minus x, because 7 minus x would mean x less than 7, right? So 7 fewer than a number x would actually be x minus 7, right? 7 fewer than this number x, okay? So that is the general principle that we're going to be dealing with when we start looking at words and trying to come up with a numerical expression for them. So, like, let's say this one, 5 fewer than a number is, okay, and this is a new introduction. Before we just had the expressions, right? Is indicates an equation or inequality, depending on what the rest of that sentence is, okay? So this is going to mean you're going to use an equal sign or greater than or equal to, or, you know, something like that, etc. So, in this example, 5 fewer than a number is at least 12, okay, at least 12. Okay, this is the key part. At least means that this expression can be 12 or it can be bigger than 12. So first off, let's break down this part. 5 fewer than a number. Well, we just looked at an example with 7 fewer than a number, so we know x minus 5 really you can use any variable. I'm just using x because it's like probably one of the most commonly used letters for algebra. I don't know why, but maybe it has to do with Cartesian plane, the Cartesian grids, you know, coordinates x, y, and z if you're working with like vectors. Yeah, that's a little physics for you, and calculus. But anyway, 5 fewer than a number, x minus 5, is at least, okay, at least, like I said, it can be 12, x minus 5 can be equal to 12, or it can be bigger than 12. So we're going to say x minus 5 is greater than or equal to 12, right? It can be equal to 12, right? So x minus 5, really this just means x minus 5 can equal 12, or, well, I guess I should say and, because it's including both parts. So we're including x minus 5 equals 12 and x minus 5 is greater than 12. So I know it's weird to say and, but really we can talk about both. So x minus 5 equals 12 and x minus 5 is greater than 12. This symbol, greater than or equal to, just combines both of these cases, okay? So now, last example is the quotient of a number and, yeah, I know my handwriting is terrible on this. The quotient of a number and 3 is no more than 15. Okay, so one thing I've noticed, unlike with differences, where you have to really watch the wording, like, you know, you can't say this up here is 7 minus x because it's 7 fewer. Well, here, when they say the quotient of a number and 3, we can just interpret that as n divided by 3. I'm trying out a different variable, so you could still use x in this case, but it doesn't really matter. So the quotient of a number and 3. So a number, n, is being divided by 3, so therefore the fraction, this fraction line really just means division. So no more than 15. So it's not saying it's less than 15, but it can't exceed 15. It can't go over 15. So this is n over 3 is less than or equal to 15, okay? Because this means n over 3 can be less than 15 and it can be equal to 15. But notice, it can't go over 15. That's the trick of it. So really just looking at this wording, I think a lot of it might kind of be a little instinctive, especially with things like, you know, no more than. I mean, I think we use these phrases a lot in regular life, like, you know, I need no more than, or I need at least this amount, you know. But really putting it into terms of, in terms of variables and numbers is a whole different section to work with. So I think it's pretty interesting. But yeah, this is just the intro into inequalities, and so that basically wraps it up for today. See you next time.